In this collab, we learn how deep learning works with geometric intuition. First, we import all the libraries such as NumPy, PyTorch, Matplotlib, etc. And here we demonstrate universal approximation theorem with 6 subplots showing increasing neurons from 1 to 200 approximating a complex Wiggly function. So here in the output we can see more neurons reduce approximation error, but we need massive amounts for a good fit. First, we create synthetic data of 2000 points with two classes separated by complex sinusoidal boundary, and which outputs scattered plot with wiggly black decision boundary, as we can see here. So here we test single layer linear classifiers with different identifications such as horizontal, diagonal, and tilted. So here in the output we can see three plots with straight line boundaries achieving poor accuracy from like 38% to 87%, demonstrate linear limitations. Here we visualize the ReLU activation function and its folding effect in 1D, 2D, single neuron and multiple neurons. Here we can see in the output how ReLU creates piecewise linear folds with multiple neurons creating multiple fold lines. Here we compare wide networks increasing neurons per layer versus deep networks, which is increasing the layers with similar total parameters. Here in the output it shows deep networks create more complex hierarchical decision boundaries despite having few total neurons. Here we define the PyTorch neural network classes shallow network with 1000 neurons in one layer versus deep network with 32 neuron across 5 layers. So in the output we print network parameter counts. Shallow has 4001 parameters and deep has 4353 params. So we plot the decision boundaries, training loss, and accuracy curves, comparing shallow versus deep networks. So here in the output, we can see that the deep network achieves slightly better accuracy, which is 98.2% versus the 97.9%, with comparable parameters, and learns a boundary closer to the true wiggly boundary. So to summarize, this collab explains deep learning through geometrical intuition, how ReLU creates folds, why depth enables hierarchical features, and why deep networks outperform uh, shallow ones.